What stands before you seems crafted for the clouds. Wrapping around the tower, this giant platform works like a factory in the sky, with the press of a button. The whole construction process begins, one step after another. A small team of workers is all it takes to keep the tower rising at about 1.2 meters a day. From the East China Sea to the Yangtze River, it is reshaping China's bridge engineering. Stretching across rivers, seas and deep canyons, it empowers engineers to build taller towers and longer-span bridges, and deliver projects with greater efficiency. On June 17, 2021, the East Tower, a key structure of the Shenzhen-Zhongshan link, was topped out over the waters of Lingdingyang. It marked a milestone under the 14th Five-Year Plan, as China's homegrown smart tower builder successfully passed its first field test. This mobile factory rises above the clouds, embodying the accumulated wisdom of generations of engineers, from CCCC Second Harbor Engineering Company. It has blazed a new trail for a smarter, more modular construction method to build super-tall concrete bridge towers. Tian Wei, Deputy Chief Engineer at CCCC Second Harbor, serves as the General Commander for the system. From the Sutong Yangtze River Bridge to the Hong Kong-Zhuhai-Macau Bridge, and then the Shanghai-Nantung Yangtze River Bridge, Tian has helped build lots of China's landmark bridges over his two-decade professional career. Project by project, new technology broke technical barriers and set new world records. Yet records were never Tian's goal. His true pursuit and real ambition lay in revolutionizing the entire methodology of bridge construction.
In the 20 years I've been in this field, I have seen everything change at a truly breathtaking rate. As bridges grow bigger, the technology keeps evolving, so there's real pressure. At this stage of development, we simply cannot rely on the old way of doing things. We have to completely rethink and reshape our entire construction workflow.
In September 2018, work began on the Shenzhen-Zhongshan Link's bridge section, a key Greater Bay Area transportation passage. At its heart is the Shenzhen-Zhongshan Bridge. Two main towers carry it across Lingdingyang waters. At 270 meters tall, they were designed to set a new standard for ultra-long-span offshore suspension bridges. But Lingdingyang imposes formidable challenges to construction operations. It sees force 6 or higher winds over 200 days a year. Salt air, heavy humidity, and frequent high winds compounded difficulties throughout all construction phases.
As you can see here, wind speeds recorded during construction have hit 37 meters per second. That narrows the window for superstructure construction and complicates things like equipment and vessel scheduling and construction planning.
Building a 270-meter tower in the middle of Lingdingyang needed not only to meet extremely strict quality standards, but also fight the harsh weather almost every day. With such a tight construction window, the project demanded rigorous control over safety, quality, and efficiency. Nevertheless, the old method was fragmented and slow. All processes ranging from rebar tying to pouring and curing relied heavily on manual labor. Working high above the sea was risky, and moving equipment and materials was tough. That approach failed to keep up with the demands of the offshore megaproject.
It was our predecessors who showed us how to build bridges, not just to get the job done, but to achieve truly world-class standards. They were the true pioneers. Now it's our turn to carry this work forward. We have to make it smarter, cleaner, and more precise than ever before.
In Tian Wei's opinion, taking that next major leap forward called for a clean break from the old construction methods. His team came up with a groundbreaking idea: to replace the exposed construction site, battered by constant sea winds, with a highly organized sky factory, which is capable of moving at height. A smart control system would run it all, with fewer hands, less risk, higher quality, and faster work. Nevertheless, creating such one-of-a-kind equipment from the ground up meant tackling an engineering challenge that had never been attempted before.
Pressure was huge. But so was the drive. We really wanted to take it on.
When Tianwei first started out, older engineers had already paved the path, bringing the China-made hydraulic climbing formwork into major bridge projects and laying the groundwork for future megaprojects. Now leading the tower building platform project, Tian saw the next step clearly: to go from merely catching up to leading the field. Bridge construction had to become more industrial, more automated, and more intelligent.
Li Bazhou is a highly hands-on person, and much of his project experience could be built into our tower building platform.
By this point, Li Bazhou had dedicated 17 years to researching smart equipment and bridge construction technology. Over those years, he grew into the kind of engineer who could handle intricate technical details and see the bigger picture. That was exactly why Tian entrusted him with overseeing the platform's system design and overall machine layout.
Cast-in-place bridge towers are built in a very complex setting. At that time, there were no mature examples for fully mechanizing this construction process, which made the whole undertaking an enormous challenge. Still, I felt really excited when I was assigned this project.
Li is known for being practical and precise, and willing to embrace innovative thinking. He saw every difficulty as an opportunity to create something new. That's why he went straight to the job site.
Guys, when you're pouring concrete on site, what gives you the most trouble?
For our crews working on site, pouring concrete.
What Li wanted was far more than an ordinary mobile working platform. His goal was to develop smart equipment that would make tower work safer, easier, and faster. Li's team therefore stayed on the construction site to talk with workers and technicians. They studied the hardest construction procedures and mapped out what the job really needed. After 2 months of repeated discussion and revision, the design blueprint for the mobile platform gradually took clear shape.
Traditional hydraulic climbing formwork is limited, and work is scattered. We wanted it to work like a mobile factory. It would combine low-position climbing construction, concrete pouring, concrete curing, along with worker-friendly features, all in one system.
After reviewing over 1,000 pages of documents and refining the plan through a dozen rounds, Li's team finally came up with an innovative and groundbreaking design. Under their scheme, the tower building machine had 8 circular work decks, each built for a specific task. The work zones were separated so rebar tying, concrete pouring, and curing could run at the same time. Tower construction became far more efficient. At the center was a smart control system, the platform's brain. It linked automatic climbing, machine-assisted work, emergency response, and real-time safety monitoring into one network. The team also added sanitation, fire safety, sun covers, and rain protection. A smart mobile factory above the clouds began to take shape. The design was complete. The prototype was built. Now the critical test awaited. Could the equipment perform reliably on an actual construction site?
Lower the vibrating rod. Wait, this one is catching. Guys, lift it a little. That part's loose, right? It's the bolt. It isn't holding, right?
What stands before you is no ordinary machine. The tower building platform combines materials science, mechanical design, electrical systems, and automation. Every detail can determine to whether the project succeeds or fails.
The vibrating rod jammed while we were lowering it. The drive unit had a small issue. The vibrating rod got stuck. Actually, The whole system is really complicated, especially out on site, where nothing is fully predictable. The biggest challenge is making sure all the different devices run smoothly together. That's why we carry out multiple rounds of testing, both in the laboratory and at our workshop base.
After numerous theoretical calculations and on-site trials, Li Bajou's team finally devised the optimal industrial construction workflow. But making a steel giant weighing hundreds of tons operate precisely and steadily at height was only the first of innumerable challenges.
Stability is critical. This platform is heavy, yet it barely has any supporting points. We rely on 8 hydraulic cylinders lifting the full system together. Each of the 4 climbing units sits at a different angle. Once any single cylinder falls out of sync, the frames will pull against one another, and that could tip the whole platform over.
For the construction of the Shenzhen-Zhongshan Bridge, the 400-ton platform structure needed to ascend along a fixed incline trajectory. Then, 79 meters up, it had to shift direction in midair. Such an operation was practically impossible to pull off, and the team could not come up with a workable plan for a long while.
We had lots of problems like that. Still, as an engineer, I've always maintained an optimistic outlook. What we really hope is that as many problems as possible will come to light. That way we can fix them, draw lessons from them, and make the system better.
Li Bajou drove the team to forge ahead unwaveringly. Equipped with calm and resolve, they sought solutions to the engineering dilemma across 2 aspects: structural layout and control systems. From a mechanical perspective, Li Bajou's team reinforced the climbing system with strong, flexible joints. In terms of digital control, they improved the algorithms, so the control system could accurately track every change in position in real time, and carry out prompt adjustments to angles and operating speeds accordingly. That made the climb steady and precise. Following 6 months of development and testing, Li Bajou's team built a smart overhead mobile factory to speed up the construction of high-rise towers. They also drafted the industry's first standard for industrialized construction of concrete bridge towers. Nevertheless, for reinforced concrete towers, rebar cages carry equal significance, as their quality directly determines the strength and service life of the towers. Traditionally, rebar was tied high up in the air. The work was slow and required extensive labor. Accuracy was hard to control, affected by weather, site conditions, and human error. A mistake, no matter how tiny, could escalate into a major safety threat. With the evolution of bridge, tower construction methods, the industry urgently required innovative approaches to rebar cage fabrication.
Cheng Maolin is full of good ideas most of the time. When there's no playbook and everything has to be worked out step by step, he never slows down and keeps pushing forward.
Cheng Maolin is a senior chief engineer at CCCC Second Harbor. His fellow engineers see him as a perfectionist who pushes himself relentlessly. But as Tianwei sees it, genuine innovation depends on practitioners who will never overlook even the smallest details.
We've been on this rebar for 3 days already.
To be honest, tying this rebar is really hard.
Exactly.
In the eyes of most engineers, the solution appeared straightforward. Tie the rebar on the ground, lift it into position, and call it prefabrication. For the tower building platform, that seemed enough. Cheng, however, held higher standards. For a smart mobile factory to operate efficiently, its complete workflow also demanded matching innovative upgrades.
We could build all the rebar cages down at ground level first, and hoist them up to install up top. That would move the work down and make the whole site much safer. Even with that benefit, it still would not solve the problem of heavy manual labor. Plus, the quality control would still be like the old way.
So what was the choice? Tie rebar by hand on the ground, like everyone else, or develop an entirely new, mechanized production line, dedicated to prefabricated rebar components? After 2 sleepless nights of deliberation, Cheng Maolin made up his mind to take the tougher path.
If we just throw people at it, we may still have serious problems. What if we redesign the whole structure so we can put it together In separate modules?
No one's ever done something like this. But after hearing your idea,
Tian saw the value in the idea and gave it his full support. Nevertheless, working the concept into a practicable plan remained Cheng Maolin's biggest hurdle to overcome. The bridge tower's rebar cage resembles a multi-layered frame that keeps changing shape. Each cross-section differed slightly in size and angle, and in its rebar configuration. That makes it hard to put on a production line, which is exactly why the fabrication process has always depended on skilled hands. Cheng Maolin's idea was to break down that changing three-dimensional frame into standardized modular units. These modules needed to be easy to move and easy to hoist, and engineered with enough precision to fit together hundreds of meters up. No one in the industry had ever accomplished such a feat.
We all know that the tougher a problem gets, the greater the opportunities and the stronger the industry demand. The industry needed this solution the moment that clicked for me. I knew we had to rely on new ideas to get ahead.
The rebar frame resembles a set of nesting dolls, a layer inside another layer, yet its cross-sections differ all the way from top to bottom. That gave Cheng his breakthrough. When split horizontally, the whole frame breaks down into independent layers. Each layer can then be cut lengthwise into flat panels that can be joined together on site. At that moment, a solution presented itself for this previously insurmountable challenge.
This is exactly how we converted the original three-dimensional structure into flat panels. Thanks to this change, we were able to standardize components, use machines for production, and build it in a factory.
From that point onward, Cheng Maolin and his team ran through countless trial designs, working through each step of prefabricated rebar production. They were entering areas no one had touched before, which allowed them to pull far ahead of existing industry standards. Progress, however, did not come without obstacles. Each new idea brought its own unique difficulties. Instead of tying rebar by hand, they planned to produce integrated mesh and modular parts on a production line. The biggest challenge for Cheng Maolin became how to ensure secure connections at every bar intersection.
As you can see, when two bars cross each other, the connection is a small spot weld. We have to keep the welding tolerance within 3 millimeters. That is the only way to give the joint enough stiffness. If any weld isn't done right, the whole module might come apart when we lift it, as high as 200 or even 300 meters above the ground. That would pose an extreme safety hazard on the construction site.
Each rebar mesh panel has at least 1,600 welds. They could weld them by hand, the traditional way, or they could develop a machine to handle this tiny process. Trivial as this step might seem, it shaped the whole system. Unsurprisingly, Cheng Maolin once again refused to settle for mediocrity.
Equipment makes smart construction possible. To get this whole system running smoothly, designers, manufacturers, and construction workers, and specialists from every discipline had to work together. Groundbreaking innovations often come down to the smallest of details. To tackle the welding bottleneck, Cheng's team developed an auto-positioning welding robot. Cheng's team delivered full automation for bridge tower rebar fabrication, covering cutting, shaping, and final welding. This innovative technology filled a critical gap within industrialized rebar construction. The production efficiency went up 60%, while tower top labor was cut by 70%, and the old problems of slow work, inadequate precision, and high safety risks were finally addressed. In June 2020, the world's first smart production line for rebar modules, and the world's first smart tower building platform, were put to work on the Shenzhen-Zhongshan Bridge. Together, they formed a vertical prefabrication factory for concrete bridge towers. The system saved 30 days on the project and moved cast-in-place concrete operations from conventional on-site construction towards smart industrial production. But even as the breakthrough won praise across the industry, Tian Wei was already charting the next course forward. For his team, the next round of challenge had already begun.
When we started, in 2014, the towers still used traditional, hydraulic climbing formwork technology. 5 years later, we had the platform. That's what we engineers do. We keep finding problems and solving problems, and that's how we drive continuous upgrades for all our products.
For Tian Wei's team, each problem became the next target. And every step forward pushed the technology to new heights. After the Shanzhong Bridge, the team continued refining the tower building platform, optimizing it for lighter weight and higher efficiency. In December 2021, the second-generation tower building platform entered service on the Longtan Yangtze River Bridge. It was lighter, less expensive, and more attractive, and easier to use. Yet for Tian's team, the journey of innovation was far from finished.
At first, the tower building platform was built just for a single specific project. But nowadays bridges have all kinds of different shapes and meet far more diverse demands. So things are totally different now. We started wondering how this custom-built system could adapt to a wider range of project needs. That was our next big challenge.
Tian Wei held the view that, for this mobile factory to achieve greater breakthroughs in bridge construction, it had to evolve past customized design and grow into a fully adaptable system. This pivotal mission was entrusted to Lu Bin, a young engineer who had grown and matured through the development of the first 2 platform versions.
I thought this idea was totally groundbreaking, and the product itself was excellent. So deep down I really wanted to lead this project and bring my own unique creative insights into its development.
For Lu, a young engineer, leading the tower building platform's universal upgrade was both a rare opportunity and a demanding professional test. He started the project with great enthusiasm, yet the deeper he looked, the more complex the job became.
I've noticed no 2 bridges in China are exactly the same, mainly because their towers all look different. Some towers are shaped like an A, plus some towers are shaped like an H. Some stand as single shaft designs, with the same section all the way up. Our goal was to create one system that could fit them all. A-frame, H-frame, different shapes, different projects.
To work on different bridge types, the tower building platform needed to be adaptable and transformable, almost like a transformer platform. Yet how could the engineering team create such a high degree of flexibility in such a bulky steel framework? This marked Lu Bin's first major technical hurdle. He had no definite solution at the start. Even so, his involvement in developing the first 2 generations taught him one truth: persistent exploration would always lead to a path forward.
One day I was playing with Lego at home and an idea popped into my head. What if our steel structures could work just like that? We could make separate steel parts, drill rows of holes in them, then assemble them in different configurations. Then we could be free to change the height, width, and shape however we needed.
Lu drew inspiration from Lego to achieve this breakthrough. His team broke the tower building platform into standardized modules of varying dimensions. By recombining them, the same system could fit straight towers, slanted towers, diamond-shaped towers, and other variants. Up to the present, the 3rd generation tower building platform has been put into use on Changtai Yangtze River Bridge, Shuangliu Yangtze River Bridge, Yanji Yangtze River Bridge, and many more bridges. Different sites, one flexible universal system. The upgrade proved a resounding success.
China's bridge industry has reached a new stage. It is not just us. You can see many companies are competing with each other, pushing each other forward, and ultimately making progress as a team. I truly believe we will have a much more intelligent platform in the future, one built more around people. We can build more than bridges over rivers, lakes, and seas. We will build projects that connect people to a better tomorrow.
Above the sea of clouds, bridge towers stretch endlessly toward the horizon. Genuine progress, however, is never just about how tall one tower can reach. What matters is constantly pushing our technology further. Propelled by this endless drive to innovate, China's smart manufacturing enters a brand new era. Steel structures still rise through the clouds to this day. Our pursuit of breakthroughs carries on with the wind. Crossing rivers, passing through mountain gorges. Heading for every distant shore still waiting to be connected.